Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 2 of a unit motion in a plane. So let's begin with today's class. In today's class we are going to discuss about the part 2 of a vector. In previous classes we have discussed that what is vector, how it should look alike, what should be the angle between two vectors, and if two or more than two vectors are acting on a point simultaneously, then what should be the magnitude of a resultant vector and what should be the angle of that resulting vector with horizontal axis. Yes, so what was it? It is something like this, that if two vectors are there, vector p and vector q, and if these two vectors are acting on a same point by certain angle theta between them, then the resulting vector having a magnitude of r is equals to root of p square plus q square plus 2pq cos theta, and its angle with horizontal axis is alpha is equals to tan inverse of q sin theta divided by p plus q cos theta. Yes, I hope this is clear. So let's look at the some special cases with this results. Yes, look at this first case. They said when theta is equals to 0, it is the case of the parallel vectors. Now what is parallel vectors? Then say let's, this is vector p suppose, and this is vector q. As you can see this, that these two vectors are parallel to each other, or rather I can say that the angle between these two vector is 0 degree. So if two vectors are acting at a certain point or on a certain object simultaneously, then I need to find out the resulting vector. So let's first work for the magnitude of the resulting vector. So what I can have is that I should write like r is equals to root of p square plus 2pq cos 0 degree plus q square. As I know cos 0 degree is 1. So this is equals to r is equals to root of p square plus 2pq plus q square. If you see this very carefully, then you might know that this is the expansion version of p plus q whole square. So this is equals to r is equals to under root of p plus q whole square, and which gives me an r is equals to p plus q. Yes, what would be its direction with x-axis? It's in tan alpha is equals to q sine 0 divided by p plus q cos theta. I know that sine 0 is 0 degree, so this alpha equals to 0. That means it is on the horizontal axis only. Yes, I hope this is clear to you. Yes, if you understand this case with a practical example, then you might understood that this is the case we are doing it from probably from the ninth class. That let's say suppose some block is there, and it has been applied by the one of the 4 Newton force and another is the 7 Newton of force. If these two forces are acting on the same direction, then the resulting force will be equals to 11 Newton. That we know. That's a This is the thing that we know, that if we are going to pull this block by two forces in the same direction, 4 Newton and 7 Newton, with the help of, then total force I am acting on this is 11. How this 11 comes? With the help of this, r is equals to p plus q. I hope this is clear to you. Is it? Is it? Is it clear? Yes. So this is r, which gives me an r is equals to p plus q when two forces or two vectors are parallel to each other. This is even the condition to form maximum resulting vector. This is the maximum resulting vector. I'm talking about the magnitude. Yes, this is the case of the maximum resulting vector. You cannot form any resultant greater than this. So please remember this. Let's look at the next case. This is the second case when theta is equals to 180 degree. They are the anti-parallel vectors. When theta is equals to 180 degree, they are the anti-parallel vectors. Something like this. That this must be the vector p, this must be the vector q. If you can see this very carefully, then these two are the anti-parallel vectors and their theta is equals to 180 degree. So if such is the case, if such is the case, then what I can have is that r is equals to under root of p square plus q square plus 2pq cos 180 degree, and cos 180 would be minus 1. As cos 180 minus 1, then let me replace the value of cos 180. It would be an under root of p square plus q square minus 2pq. So this is equals to p minus q whole square, whole to in the square root. So this is r is equals to p minus q, and its value, its angle with horizontal axis is tan alpha is equals to q sine 180 degree divided by p plus q cos 180. As I know that if p is greater than q, if p is greater than q, then the alpha would be equals to 0, and if p is less than q, then the alpha would be equals to 180 degree. I hope this is clear. Practical example, something like this, that let's suppose this is block which has been pulled by 7 newton. This is another force on the same block, 4 newton. Then you might know that this F net, that you are pulling this here from 7, you are pulling this here from the 4 newton, then this F net would be equals to 3 newton. How this arrives? That we know that it's a 7 minus 4. Why 7 minus 4? Because this is the case. R is equals to P minus Q. I hope you remember this. Yes, this is the case of minimum resulting vector. Yes, this is the case of the minimum resulting vector. Is it clear? Shall we move to the next case? Are you ready? Let's move on. This is the third case when theta is equals to 90 degree. That means two vectors are mutually perpendicular to each other. Let's look. This is P, this is Q. And angle between these two vector is 90 degree. So if I go for the magnitude, then it would be r is equals to root of p square plus q square plus 2pq cos 90 degree. As I know, cos 90 would be a 0, as cos 90 would be a 0. So only the remaining term would be equals to root of p square plus q square. As well as when I find out the tan alpha, it's in q sin 90 divided by p plus q cos 90. I know that cos 90 is 0, but sin 90 is 1. So this is q divided by p. Practical life. How could I associate it with this? That this is 3 Newton, this is 4 Newton. These two are perpendicular to each other. When we don't know the vectors, we know that probably this would be the resultant. And if this is 3 Newton, this is 4 Newton, then this must be a 4 Newton. At that point of time, we know the Pythagoras because this is the 90 degree. So if this is 3, this is 4, then I must know that this is 5 Newton. How it arrives? This phi is equals to from under root of 3 square plus 4 square. Yes, it is 5 square. So the thing will be look like this. I hope this is clear. Yes, now we know the vector, so we can use this relation. R is equals to root of p square plus q square. Is it clear? Are you done with this? And any doubts? Any doubts? Is there any? No? So let's move to the next case. A very interesting case. That if two vectors are equal in magnitude and having an angle theta between them, something like this. This is, let's say, vector p, this is, let's say, vector q, this is angle theta, but p is equals to q. I'm talking about the magnitude. Then what happens? What would be the case? So let's have a look. I know that r should be is equals to root of p square plus q square plus 2pq cos theta. if I replace this value p equals to q, then it could be written as p square plus 2p square cos theta. Yes, if such is the case, then p square plus p square, this is equals to 2p square plus 2p square cos theta. So I can write like this, as this is 2p square into bracket 1 plus cos theta. Now what can you write? What can you write for under root of 2p square into bracket 1 plus cos theta? Do you know any mathematical identity which can replace this? Do you know any of them? Do you know any of them identity which can be used? No? So let's first go to that identity, and we are coming back to here. So let's first look at those mathematical identities. They are the trigonometric functions or formulas. One of the formula is that it's a sine 2 theta. This can be written as 2 into sine into half of the angle. Look at this. Here the angle was the 2 theta. So what I can write is it's a 2 into sine into half of the angle into cos of the half of the angle. This is 2 sine theta into cos theta. Second, it's a cos of 2 theta. So what I can write is that cos square half of the angle, that means theta, minus of sine square half of the angle, that is even right, can be written as a theta. So if I replace this cos square theta with 1 minus sine square theta, this is 1 minus of sine square theta minus of sine square theta. So this would be 1 minus 2 sine square theta. This is equals to cos of 2 theta. If I want that sine square theta, want a value of sine square theta, then that can be written as that 2 sine square theta should be is equals to 1 minus cos double of theta. It's a 1 minus cos theta. So the sine square theta should be is equals to 1 minus cos 2 theta divided by 2. This can be remember. Yes, this is to be learned. Are you sure? Yes. One more identity could be there with this relation only, cos 2 theta. Yes, what it could be. So as I have replaced the cos square theta, even I can do the same thing with sin square theta as well, and it would look like this. Let's have a look. That our relation was cos of double theta is equals to cos square half of the theta minus sine square half of the theta. Yes, so this is equals to cos square theta minus of sine square theta, that means 1 minus cos square theta. So this is equals to cos square theta minus of 1 plus cos square theta. This cos square theta plus cos square theta, it is a 2 cos square theta minus of 1. This is equals to cos double of the angle. This is cos double of the angle. So if I want the value of cos square theta, it could be written as cos square theta should be is equals to 1 plus cos 2 theta divided by 2. This is the relation of cos square theta. I hope this is clear. Is it? Is it clear? So please remember this identity. We are going to use this. We are going to use this very often. Yes. So shall we move back to this? Shall we? Okay, let's move on. Then my I am having this, that r is equals to under root of 2p square into 1 plus cos theta. Yes, if it is a 1 plus cos theta, what would be the situation? Look at this. If I write this, it's a 1 plus cos 2 theta. Suppose this is 1 plus cos 2 theta. Then that should be 2 cos square theta. Or if you look at a different manner, it's a 1 plus cos double of the angle, then this should be 2 cos square half of the angle. I hope you understand this. Yes, so if it is a 1 plus cos 2 theta, then it would be a 2 cos square theta. So if I replace this, then this is the situation. If you understand this very nicely, it's a p square plus q square plus 2pq cos theta. And if I replaced, if p is equals to q, then what I am having is that currently I am at this situation. It's a 2p square into bracket 1 plus cos theta. Yes, so if it is the situation, then I can write like it's a 2p square into bracket 1 plus cos theta. It is a 2 cos square theta by 2. So if I solve this, it's a 2 into 2, 4. If I take it out of the square root, it's a 2. This is p square. It's a p. It's a cos square. It's a cos of theta by 2. So this is the resulting vector's magnitude, that r is equals to 2 multiplied by any one of the vector multiplied by cos into half of the angle. This is cos theta by 2. It is an half of the angle. I hope this is clear. Is it? Is it clear? Is it clear? Yes. Is it clear? Yes. So it would look something like this. Let's say suppose this is first vector p, this is another vector q, and they are having an angle of 60, and I know that magnitude of p is equals to magnitude of q. Then I can have this value r is equals to 2 multiplied by p multiplied by cos of 60 by 2. So this would be equals to 2 into p into cos of 30 degree, and then it would be under root 3 by 2, and you can solve this. Is it clear? Is it clear? Are you sure? Are you sure? Okay, so this is about the magnitude of the resulting vector. But if in this case I want to find out the angle also, what it would be? Let's have a look. That this two are the vectors. Let's say this was the p, this was the q, this was our resulting vector, and we were doing something like this. I'm going to plot a perpendicular on this, and this was the theta because this was the theta. Yes, so this is the angle alpha. This is the angle alpha. So what you are going to do is, that it's a q, this is q, this would be the q cos theta, and this would be the q sin theta. I hope you understood this now. So if I write 10 alpha, then it would be q sin theta divided by p plus q cos theta. In my situation, p is equals to q. In my situation, p is equals to q. So if I replace this with the p, it's a p sin theta divided by p plus p cos theta. So now what would be the situation? Look at this very carefully. The 10 alpha can be written as, this is p sin theta. Shall I go back to that? Yes. Look at this. It's a sine double of angle. So what I can write is, it's a 2 into sine into half of the angle into cos half of the angle. So I can write the same thing. It's a p multiplied by sine theta. That means it can be written as 2 sine theta by 2 into cos theta by 2 divide by, it's a p into bracket 1 plus cos theta. So if I solve this, it's a 2 into p into sine of theta by 2 into cos of theta by 2 divide by p into 1 plus cos theta. It's a 2 into cos square into theta by 2. Yes, this p and p cancel, this 2 and 2 cancel, this cos theta by 2, this cos theta by 2 would be a cancel. So this is sin theta by 2, this is cos theta by 2. That would be a tan of theta by 2. That should be equals to tan of alpha. That means alpha should be is equals to theta by 2. It's an angle bisector. It's an angle bisector. I hope you understand this. Yes. So let's summarize the special case because this is going to be used. This is going to be used in a very nice manner. That this was the case that let's say this two vectors are there. This is vector A, this is vector B, and they are having an angle theta. Now, the case says that if magnitude of A and magnitude of B is the same, if magnitude of A and magnitude of B is the same, then the resulting vector will be 2 into A into cos theta by 2. Simply, that's it. And and the resulting vector would be angle bisector of this. This is theta by 2. I hope this is clear. Is it? Any issues? Any concern? Any doubts? No? So please remember this. This is very interesting and this is very special kind of case. Yes? Can you do this? Are you sure? So let's have certain numericals based on this. Yes? We will have fun. So let's begin then. What you need to do, you need to find out the resulting vector. Always you need to find out the resulting vector. That situation is something like this, that suppose on this point one of the force is acting which is 4 Newton, another force is acting which is of 8 Newton. Yes. So what they ask, find out resulting vectors magnitude. Say this is first case. So I know that this and this both are in opposite direction. These two are in opposite direction. So when they are in opposite direction, my R would be equals to P minus of Q. Let's say suppose this is P and this is Q. As this is bigger, it's an 8 Newton, it will dominate, and as it will dominate the net, the magnitude of R, it would be a 4 Newton. Yes, it is in this direction. This means it's in negative x direction. This force is acting on the negative x direction. Yes. Next, let's say this point is there. Here one of the force is there, it's an 8 Newton. Another force is there, it's an 4 Newton. If I find out the mode of R, it, as this two are in same direction, it would be an 8 plus 4, and this would be a 12 Newton. So this R is in positive x direction, that you can understand very easily. Yes, it's an 8 Newton and 4 Newton. Now next, third case, let's say situation is something like this. This is first vector, this is second vector, this is 5, this is 5. Let's say 5 Newton. So mode of R, it's a 2 into P into cos theta by 2. I hope this is clear. So this is equals to 2 into 5 into cos 90 by 2. It's a cos 45 degree. And cos 45 is 1 by root 2. It's a 10 into 1 by root 2, which will give me a 5 root 2 Newton. And its direction, it would be an angle bisector. As you can see, this is 90 degree. This would be 45. Magnitude would be 5 root 2. Is it clear? Is it? So can you do this? Can you do this? Are you sure? Can it be done? Can it be done? Yes, let's have a look somehow and some typical questions. That this is the 8 Newton, this is the 4 Newton, this is the 4 Newton as well. Find out resulting vectors magnitude and direction. direction. How can I do this? First, look at that I have a relation for only two vectors. It is a root of p square plus q square plus 2pq cos theta, and I don't know that if three vectors are there, what should be done. But what my common sense guides me, that if you are having a more than two vectors, you can solve this by taking two vectors at a time, and things will be done. So if I understand this scenario, then what I can have is that this is the 8 Newton force, and this would be the 4 Newton of force. So if I make a resultant of this, then I can have this is only the left with me. It's a 4 Newton of force in positive x direction. How this arise? That I have done, it's an 8 minus of 4, and the 4 Newton has remained. And as 8 Newton, more force is dominating, and it is in the x direction, so my resulting vector, which will be the remaining vector, would be in 4 Newton. So this would be the first situation. If this would be the first situation, then I am left with this situation, that this is 4 Newton, again this is 4 Newton, yes, and as this two are the same in magnitude, and they have an angle of 90 degree. So what I can have is r is equals to 2 into 4 into cos of 90 by 2. It's in cos of 45 degree. Cos 45, it's a 1 by root 2. So this is 2 into 4 into 1 by root 2, and this would be is equals to 4 root 2. This is 4 root 2, which is in the x direction, which is making an angle of 45 degrees. So this 3 can be represented by a single vector, which is acting at the 45 degree with the x-axis and having a value of 4 root 2. So if I need to replace these three vectors, I can simply draw this. This is x-axis, this is the vector, it's a 4 root 2, and their angle from the x-axis would be 45. That's it. Is it clear? Is it? So can you do this? Is it possible? Yes? Will you able to do this? Okay, let's have a look. The next question. Suppose this is, let's say, 10 Newton. This is 5 Newton. This is, let's say, 7 Newton. This is 2 Newton. And let's say this is point P. So they was that find net force acting at point P. This is the requirement. How could I do this? How could I do this? So if I see this, this is 10 Newton, this is 5 Newton, and these two are the exactly opposite to each other. That means they are aligned to each other with the angle of 180 degree. What I can do is, it's a 10, it's a 5. So my remaining term would be in positive x direction, and that remaining term would be a 5 Newton. I hope this is clear. This is the first case. Now second is that it is 7 in Newton in upward direction, and it is 2 Newton in downward direction. Again the angle, it's a 180 degree. So the remaining term will be equals to a 5 Newton. How I did this, it's a 7 minus 2, p minus q kind of thing. Yes, so I am remaining with this. It's a first, it's a second, and these two vectors are acting at a point P. So if these two vectors are acting at a point P, the situation would be something like this. It's a phi. It's a phi. Yes. So magnitude the same. Angle is the 90 degree. R is equals to 2 into phi into cos 90 by 2. It's a cos 45. So this would be a phi root 2 Newton. Direction. Its direction would be, it is an angle bisector. So if it is an angle bisector, it would look like something like this. It's in 45 degree. Is it clear? Is it clear? Yes. Can you do this? Can it be? Okay. Let's move on to one more question. Let's say this is first vector, this is another vector. Let's say this is of 6 Newton. Again, this is of 6 Newton. And this angle is 120 degree. This angle is 120 degree. This is the point P. One more vector is there. One more vector is there which is in this direction. This is of 3 Newton as well. And this is having an angle of 60 degree. And you have been asked the same thing, that find out net force acting at point P. Find out net force acting at a point P. What it would be? What it would be, and how can you do this? So can it be done by you? Can it? So let's have a look. That first I need to solve by two vectors. It is something like this, that this is the 6 Newton. This is the another vector. This is even of 6 Newton. This would be a 120 degree align. So first let's find out the magnitude of this. If I find out the magnitude, it's r is equals to 2 into 6 into cos of 120 degree by 2. It's a cos 60. So this is 2 into 6 into cos 60. It's in half. So it would be a 6 itself. It is the 6. And its direction, as 2 are the same in magnitude. As 2 are the same in magnitude. So what I can have is it's an angle bisector. It is at 60 degree. I'm left with this. So now if I consider the situation with question, then I can have is that my first angle given by the question, it is of 3 Newton, and another vector, it is on the same direction having a magnitude of 6. So if I observe this carefully, this between this two, a theta is 0, and if it is theta is a 0, r resultant would be is equals to P plus Q. It's a 3 Newton plus 6 Newton. That would be a total 9 Newton of force is acting. Total of 9 Newton of force is acting at a particular point P. So is it clear? Is it clear? Are you sure? Can it be done? Can it? Okay. So let's move to the next. Let's move to the next. Let's say this is 3 Newton. This is 4 Newton. And this is point P. They have asked us that find net force acting at point P. This is the requirement. Find out the net force acting at point P. So what can I do? What can I do? First thing, angle between these two are 90 degree. So if it is an angle is 90 degree, what I can have is r is equals to root of p square plus q square. If I do this, it would be an, it's a under root of 3 square plus 4 square. So this is 5. So it looks like something like this, that these are the vector. It's a 3 Newton, it's a 4 Newton, and my resultant is in this direction. This is 5. So does it an angle bisector? Did it? No. Now I am interested in this theta. How could I find it out? Then what I assume is that if it is a 4 Newton, even it is the parallel side, so it would be the same 4 Newton. Yes. Now tell me, do you know the magic triangle? Do you know magic triangle? No? No? Okay. Let me show you something. That suppose, mm, suppose this is the triangle. This is 3, this is 4. It is obvious that this is 5. Yes? And you can see that this is 90 degree. This is 90 degree. So if this is 90 degree, then angle between 3 and 5, it would be an 53 degree. Angle would be a 3 and 5 would be a 53, and angle would be this. If you can observe this, it's a 53, it's a 90, so only the 37 has been remained, so it is 37 degree. Even you can, this is the magic triangle, this is the magic triangle, and you need to remember this. Yes, if it is the case something like this, let's say this is 4, this is 3, that means this would be the 5. This is 90 degree, this is 90 degree. So angle between 4 and 5 would be always a 37, and angle between 5 and 3, angle between 5 and 3 would be a 53 degree. Now you can have a value whichever you want. You know that what is sine 53 and what is cos 37 and what is tan 37 and sine 53, tan 53, cot 53, and everything you know. If you remember this, if you remember this, this can be done. I hope this is clear. Yes, these are the magic triangles. These are the magic triangles, and this magic is to be done by you people as well. So this theta, it's an angle between 3 and 5. So this theta would be equals to 53 degree with with x axis. I hope this is clear to you. Is it? Is it? Yes. So can this be done by UPIs? Are you sure? Are you sure? Can it be done? Will it be? Great. So let's move to the some more numericals. Let's have a look. What they ask is that the question is about the maximum and minimum resultants of two forces are in the ratio of 4 is to 3. When it is a maximum, yes, when they are added, that means if two forces are then F1 plus F2. And minimum, when it would be a minimum, it would be a subtraction of this two, it's an F1 minus F2. I assume that F1 would be greater than F2. If I assume F1 would be greater than F2, it would be an F1 minus F2. They said the maximum and minimum resultant of two forces are in the ratio of 4 is to 3. So this is F1 plus F2 divided by F1 minus F2, and this is 4 is to 3. The forces, I require the forces. Let me have a cross multiplication. It's a 3F1 plus 3F2 is equals to 4F1 minus 4F2. And let's try to solve this. It's an F1 equals to 7F2. So this is F1 is to F2. It is 7 is to 1. And this would be the answer. Yes. Do you land on the same answer? Do you? Yes. Do you have the same answer? Great. If you are not doing it, please I request you that please have your pen and paper and do it with me, because this all are the practical aspect. These are not the theoretical things that we can listen, we can remember, and the things will be done. This all are the practical aspect of a vector. We need to, I need to do this with my own hand, with my own paper. Yes, then only my own brain will work at the time of an examinations. So please do this, please do this. Let's, are you ready? Ready for the next question? Let's have it. What this says is that if two vectors have magnitudes in the ratio of 5 to 8, okay, the resultant have maximum and minimum magnitudes in the ratio of, now what is maximum? It's an addition, it's in p plus q, something like this. What is minimum? It's a p minus of q. Here it's a 5, it's a 8, so you can write it as an q is to p, or q minus p, sorry. So what we are having, it's p by q, it's a 5 by 8, and from this I can have q is equals to 8p by 5, and I know that maximum it's a p plus q, minimum it's in p minus q, and the ratio would be a 13 is to 3. Yes, very easy question. Move to the next question. What is it? What the question says is that the resultant of two forces, one doubles the other in magnitude, is perpendicular to the smaller of the two forces. The angle between the two forces is, yes, what they say is, again, the resultant of two forces. They are talking about the resultant of two forces, but which are they? The forces are, one doubles the other in magnitude. That means if one of them is x, another one is the 2x. If one of them is p, another one is 2p. Then they again back to the resultant. That resultant of two forces is perpendicular to the smaller of the two forces, and you need to find out the angle between these two vectors. So what I have did is that this is one of the vector, this is vector p, this is another vector having a vector 2p, and they said that the resultant is perpendicular. Look at this, it's in perpendicular to the smaller of the two forces. This is the smaller one, so it is perpendicular to this. This all has been given to me. So if this all has been given to me, this is p, this is 2p, and this is angle theta, what I need to find it out is, I require this angle theta. I require angle between these two vectors. So if I observe in this triangle, I know that this is p, then this is parallel side, it would be a p. If this is 2p, then this would be a 2p. Yes. So if I apply a sine theta, let's give me the name, it's a b c, this is 90 degree. I hope you understand this, that in triangle ABC, what is sine theta? The sine theta would be is equals to AC divided by BC. It's a P by 2P. It's a 1 by 2. And sine theta is equals to 1 by 2. That means theta is equals to 30 degree. If this is 30 degree, if this is 30 degree, then this is 30 plus 90. Then this total would be a 120 degree. Yes. So this would be the answer. Got it? Got it? Shall we move to the next? Let's have a look what they says. It's if mode of p plus q is equals to mode of p minus q, then the vectors p and q are, okay. So if this would be the situation, this would be the situation, or this could be the only situation, that if two vectors p and q are perpendicular to each other, if p and q are perpendicular to each other, then only this can be happen, then only this can be happen. Yes. So please remember this, or you can analyze it from here as well, that if r is equals to root of p square plus q square plus 2pq cos theta, this is the resulting vector of the addition. And when we are talking about the subtraction, it is root of p square plus q square minus of 2pq cos theta. This is subtraction. What I want that resultant of addition and resultant of subtraction would be the same. How this happens? So look at this, if I go through a trial and error method, I am having an p square, this must be a p square. I am having an q square, even it is here in q square. The different term is that here it's a 2pq cos theta, and here this is minus of 2pq cos theta. So if I want that this two are the vectors, this term would be a 0. And when it would be in 0, when cos theta would be equals to 0, and when cos theta would be equals to 0, then it is the case when theta is equals to 90 degree. Did you understand this? Do you understand this? Are you sure? So this would be the case, that if two angles are aligned to each other with theta of 90 degree, then these two vectors having same resultant, if they are added or if they are subtracted. Yes. So let's move to the next question. What they say is the resultant of two forces, of each magnitude f acting at a point is root of 2f. What is the angle between the vectors? Yes. So what they say is that one of the force f and another force is f. Hmm, let's suppose something like this, and this is their angle theta. As this is, both are having the same magnitude. What I can have is r is equals to 2 into f into cos of theta by 2, and their resultant is root of 2f. So this is root of 2f is equals to 2 into f into cos of theta by 2. So this ff cancel, and this is root 2 by 2. It's a 1 by root 2 is equals to cos of theta by 2. So it's an theta by 2 is equals to 1 by root 2. In the cos, it's a 45 degree. So this theta would be equals to 90 degree. This would be the case. Yes, I hope this is clear. Is it? Let's move to the last question of this class. Very interesting question. Go through this. If this says that if if the sum of the two vectors is also a vector of unit magnitude, the magnitude of the two unit vector is. So how can you do this? How can you do this? They says if the sum of the two vectors is also a vector of unit magnitude. So first you need to find out that what would be the angle between these two vectors. So how can you do this? How can you do this? That suppose this is one of the unit vector, this is another unit vector, and uh, let's say that this is the resultant of this vector, this two vectors. This is theta. Let's say this is x, then that must be an x. So if I write it's an r, resulting vector is equals to 2 into x into cos of theta by 2, and my value of an r must be an x. This is x is equals to 2 into x into cos of theta by 2. This x gone, and this cos of theta by 2 would be equals to half. So this theta by 2 is equals to 60 degree, and this theta should be is equals to 120 degree. Yes, so this is the case when two vectors of equal magnitude are aligned by certain angle, and its resultant would be a same angle. The resultant would be of same in magnitude, then the angle between these two must be an 120 degree. Then angle between these two must be an 120 degree. Now what you need to find out? You need to find out the magnitude of the difference of the two unit vectors. They are the unit vectors, so r is equals to root of a square plus b square minus of, minus because it's a subtraction, minus of 2ab into cos 120 degree. Yes, they are the unit vectors. I know unit vectors, it is the vectors having a magnitude of 1. So if it's a 1 square, it's a 1. It's a b square, it's a 1, minus of 2 into 1 comma 1 into cos 120 degree. Do you know the value? Cos 120? No. Please remember this. It's a minus of 1 by 2. So this minus minus has been cut. This has been cut. So this is root of 1 plus 1 plus 1. It's a root of 3. This is the magnitude of resulting vector, and this would be the answer. I hope this is clear. Is it? So what I hope is you can do these things. You can do these things, and this can be done by you guys. Are you sure? Yes. So let's wind it down here. That in this class we have been doing, and we have been practicing the questions based on the resulting vectors, their magnitude and their direction. Yes, so please practice this kind of questions. This will help us. Yes, so please practice a lot. Please practice a lot. Every time when you revise this, you need to revise from a first part of the vector, that what is the vector and what other vectors are there, and what would be the angle between these two vectors, and how could I find out the resultant and all that stuff. Yes, this will make our foundations of a vector very clear. Yes, so please revise it. Thank you. Have a good day. Take care. Bye bye.